Hey guys, let's look at a few of these subtraction problems together. We're going to find the difference between these two mixed numbers. 10 and 3/4 minus 7 and 1/4. Now this one is kind of an easy way to start because we already have common denominators. Okay, now I'm not going to do all of these problems with a visual model, but I do think to start with it might help you guys. So let's start with our total, which is 10 and 3/4. So here's 11 squares. 10 of them are going to be completely filled in. That represents our 10 holes. And then 3/4 of the 11th one will be filled in, and that will represent our 3/4. Okay, so there's our 10 holes. And then we have 1, 2, 3/4. Okay, now I'm going to cross out 7 and 1/4. This is gone, 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 gone. What's left? 1, 2, 3, and 2/4. Now 2/4 in simplest form is 1/2. So for this one, the difference between these two amounts is 3.5. Okay, let's look at this next one. 7 and 3/7 minus 2 and 8 out of 21. Now, for this one, we don't have a common denominator. We have two unlike fractions, so we're going to have to deal with that first of all. For 3/7, I'm going to convert that to some amount out of 21. So if I show you with a visual model, here's 7 equal pieces with 3 shaded. If I cut each of these 7ths into 3 equal pieces, now I have 21 equal pieces, 2, 3, 4, 5, 6, 7, 8, 9, and 9 of them are shaded. So 7 and 9 out of 21 is equivalent to 7 and 3/7. Now I can find the difference between these two numbers. Okay, so here are my 8 squares or rectangles. Now I need 8 because I've got 7 holes and then a portion of one more. So I can fill up 1, 2, 3, 4, 5, 6, 7. That's my 7 holes. Whoops. There's my 7 holes, which is this. And then I need to cut the next one into 21 equal pieces. And shade in 9 of them. So this is 7, 8, 9. Okay, now I'm going to eliminate or get rid of 2 holes. So this is gone and this is gone. And then 8 of my little pieces. So 1, 2, 3, 4. Oh wait, no, that's not going to be right. Well, okay, I can do it that way. 1, 2, 3, 4, 5, 6, 7, 8. And that just leaves me with one little itty bitty piece. And in addition to that, 1, 2, 3, 4, 5 holes are left. Okay, let's skip a few of the practice problems and go down to the word problems. Here we're learning about the relative sizes of bird eggs, which are bigger and which are smaller. They are asking us to figure out for number 11, how much longer is the Canada goose egg than the raven goose egg? So we're trying to find the difference between those two. Let's look and see how long the Canada goose egg is. 3 2/5 inches. And then let's subtract the length of the raven egg, which is 1 9/10 inches. And our answer will represent the difference between their sizes. Okay, so let's go ahead and make our visual model. And I need to have 4 squares because each square represents an inch. And we've got 3 and a little bit. Oh, that's 5. Well, that's okay. All right, so this is, red is Canada goose egg. 1, 2, 3 inches, and then 2/5 of an inch. Two-fifths. And then from that, we're going to remove 1 9/10 of an inch. The more practice you get with working with these fractions, the more you'll start to just automatically recognize which number should be your common denominator. So we need to convert this to tenths so that we'll have like fractions. And the way we do that is we're going to multiply the top and the bottom by 2, which is essentially cutting each fifth into 2 equal pieces. So now instead of fifths, I have tenths with 4 of them shaded. So we're going to do 3 4/10 minus 1 9/10. Now, if you notice, we're going to be subtracting 4 minus 9, which means we're essentially going to be borrowing. And the way you do that with a fraction model, I'll show you on here first. How do I go back? Okay, there we go. So I'm going to cut this into 10 equal pieces. So this is, well, I'll show you with the equation in a second. Okay, so now let's cross off 1 whole inch, that's my whole number 1, and then 9/10. 1, 2, 3, 4/10, 5/10, 6/10, 7/10, 8/10, 9/10. That leaves me with 1, 2, 3, 4, 5 tenths. So 1 5/10 over here. So the difference between the two is 1 5/10 inches, and 5/10, when you simplify that, it simplifies to 1 1/2. Okay, so if you are not going to be doing a well, I don't want to talk to you about the borrowing part yet. We'll just leave it at that with the area model. Let's look at number 12. How much wider is the turtle dove egg than the robin egg? So we're comparing turtle dove width to robin egg width. And we're finding the difference between those two. So the turtle dove width is 9/10 of an inch. And we're going to subtract, let's see, robin egg, 3/5 of an inch. 9/10 is going to stay the same. 3/5 is going to convert to 6/10. I promise you that converting these to like fractions will start to feel like second nature. 9/10 minus 6/10 leaves me with 3/10. So now we need to put this in simplest form. And this is something that I've been getting a lot of questions about. So let's look at that. 1, 2, 3, 4, 5. Okay, so here's my 10 equal pieces. Oh wait, no, I can't simplify that. Never mind. I'll have to save that for another problem. Well, here's a visual model for you anyway. 3/10 of an inch. Okay, let's go ahead and look at this one because this is an important idea here. We need to figure out why it is essential to rename 4 1/4 if you're subtracting 3/4 from it. Now, we already have common denominators for this, so we don't need to worry about that, which is awesome. I can subtract 3/4 from 4 1/4 because I know that 3/4 is smaller than 4 1/4, but it gets a little bit tricky here because I have a numerator that's bigger than my other numerator. So this is why it's necessary to rename this fraction in order to make it easy to subtract. I'm going to rename 4 1/4, and I'm going to call it 3 plus 1 1/4 minus 3/4. Then I'm going to say, well, 3 plus 4/4 plus 1/4 minus 3/4. I can do that. That still leaves me with this numerator being smaller than this one. So if I combine 4/4 and 1/4, that gives me 3 5/4 minus 3/4. Now I can subtract. That leaves me with 3 2/4, or 3 1/2. This might be easier for you to understand with a visual model. So here I have 1, 2, 3 holes. No, sorry. I didn't do that right. Okay. I have 4 holes. Okay, so coming back up to our original problem, I have 4 1/4, which I modeled 1, 2, 3, 4 holes, and 1/4, and I need to subtract 3/4. I can go ahead and start subtracting by crossing out this 4th, but then that leaves me coming over here and not really knowing what to do with this 1 hole. I'm going to rename this 1 hole as 4/4, which I showed you here. And then I'm going to continue crossing out. So I've got 1/4 to cross out, 2/4, and 3/4. That leaves me with 2/4 and 1, 2, 3 holes, or 3 1/2. So your job is to explain in a sentence why we had to go through that renaming process in order to subtract and get the correct answer.